Okay, so hello, welcome everyone. Hola a todos. We are streaming from Madrid. This is a pretty nice place. This used to be the official laboratory of Madrid. I think that this is a very nice place to start with this journey, which is everything, everywhere, all with KDB. Well, my name is Jesus. I'm the organizer of this meetup. Today I'm going to be the host, and I'm also the VP of Research at Habla Computing. So first of all, let me introduce you briefly what is Habla Computing and why we decided to create this meetup. So Habla Computing is a really small company. We are less than 15 people. And well, we started like 13 years ago. We've been doing a lot of functional programming and also data engineering. And I think it's fair enough to say that we are very proficient with functional programming, especially Scala, and also data engineering, mainly with Spark. So given this background, I think it's we thought that Q and KDB accommodate pretty well with our team. So we decided to start a business line around KDB and Q. And nowadays we supply consultancy services. We also supply training. We've started lately to do our own products that we plan to share with the community soon. And in these years, we could notice that especially in Spain, the KDB community is very narrow. So we wanted to pitch in our 2 cents. So we decided to start talking about KDB and Q in conferences, in meetups, and they were quite successful. So we decided to create a specific meetup for this technology. So this meetup, of course, is everything everywhere, all with KDB. And it's a meetup created by developers for developers. So it's open to everybody. So if you want to participate here, we are really happy to hear from you. So drop me a line in that case. So let's go to the important thing. I think that today we have a fantastic lineup of speakers. We have Clarke and Rebecca Kelly. They are going to introduce INQDATA and their master data as a service product. We also have Zan Buchanan from Data Intellect. She's going to show how to migrate Torque, not TorqueQ, we know that, applications into Amazon ThinkSpace. And also, of course, we have Alexander Unterrainer, who is going to help us to read, understand, and hopefully to learn KDB. So if you have any question, we have for each talk, we have a space of 5 minutes at the end for questions. So if you are online, you can post the question, and later, hopefully, we could be able to answer all of them. So that's all, and please give a warm applause to Alex.
Thank you. Good afternoon, and welcome to my presentation, How to Read, Understand, and Learn KDB-Q. I would like to thank Habla Computing for the invitation and for the opportunity to be here today. For those who don't know me, my name is Alexander Unterrainer. I am a KDB developer and consultant, and I have worked for a few investment banks in the past, Citigroup, Morgan Stanley, HSBC, UBS. Currently working for Data Intellect, the leading data and technology company in the world. I will let my colleague Zan introduce the company after. Now, I'm also the founder of DefconQ, a technology blog about KDB. Like most of you here today, I had to learn KDB at one point. Actually, I'm still learning KDB every day. And you all know KDB is quite different from all the other programming languages. The learning curve is very steep, and it can be quite frustrating to get started and to struggle with problems at the beginning. Like I myself, I struggled a lot at the beginning, and the number of times I wanted to give up and quit everything and move back to my parents, it's quite high, that number. Every time I wanted to give up, I did 10 push-ups. As you can see, I did a lot of push-ups. Okay, so in my presentation today, I would like to share a few tips and tricks with you that should make your journey easier. Now, where to start learning KDB? For me personally, the best way to start is by reading Q for Mortals. It explains you all the fundamentals of the Q language, and it's available free and online at KDB.com. At the same time, when you start learning, you should also download Q. There's a free personal edition online as well. Install it and try the exercises along the book. No other programming language makes it that easy to get started. You don't need a specific IDE. You don't need a main class like in Java. You just download Q, start a terminal, start the Q process, and off you go. Once you've finished reading the book, read it again. The more you read, the more you will know, the more you will understand what you don't understand. I've probably read the book like between 10, 15, 20 times from front to back. And every time I need to do an interview, I go back and read certain chapters again. Once you feel more comfortable with the language, you can move on to more advanced material, like, for example, Q-Tips by Nick Psaris. As you can see from the picture of my edition there, I also read it quite a few times. You can also read the Data Intellect blog, which has a lot of very technical KDB knowledge, as well as other technologies that integrate really well with KDB. Or you can check out a more recent project, Q201 by Stephen Taylor. It's his attempt to teach Q at a very technical level. Stephen is one of the KDB developers who know the language in great detail, so I definitely recommend to checking out his project. Now, before we're actually going to look at some code, let's step back a moment and have a look what Q actually is. So Q is a vector or array-based programming language specialized for big data and time series analysis. It's also an in-memory column-oriented database. It was invented by Arthur Whitney in the late 90s, and it has traces from K and A+, which are the predecessors, as well as APL. In Q, data and functions are actually first citizens, which means that Q is close to functional. It's not 100% functional because functions can actually have side effects. The main characteristics of Q is that it's very fast, so it's speed, and the throughput it can handle. Now, let's move on. A little bit of hands-on Q. Now, because this is my very first presentation, I've decided to go for a little safety net, and I will not do any live coding. So we're going to look at a few screenshots of me doing code at home. One of the main problems with Q is that it's a very terse language. So whenever you're new and you start learning, you might look at code that looks like this, and you might not really know what's going on. So by showing you this code, you probably don't understand much what's happening inside the Lambda. If I change the input a little to trim the spaces, it might give you a hint what it's actually doing. And in fact, when we execute it, it trims the spaces from the string at the front and at the end of the string. Now, if there's one thing that you're taking away from this presentation today, I want you to remember Q is left of right, which means that you read it from the right to the left. It also has no operator precedence. And another thing that I would like you to remember is always KISS. Keep it stupid simple. Now, in order to understand the no operator precedence, I'm going to show you a simple example. If you remember from elementary school or middle school, whatever, normally 2 times 3 plus 10, it will equate to 16 and not to 26. Why? Because multiplication comes before addition. However, in Q, because we're reading from the right side to the left and there's no operator precedence, it will be evaluated to 26. 3 plus 10 first, which is 13 times 2 is 26. if you want to enforce any operator precedence, you have to use parentheses. So knowing this, and by applying our KISS principle, keep it stupid simple, we can just break down the code. We ignore the input there, trim the spaces for a moment, and we only look at the lambda, which is an anonymous function. So then reading from the right side to the left, and knowing that everything within parentheses is evaluated first, we know that one reverse backslash empty space different from x is going to be executed first. Well, we can actually break this down even further. If we just take this part from the inside of the parentheses. So we can compare the empty character with trim the spaces, and we apply the smaller, larger sign, which is basically saying, where is this different from this? Now, by executing this, we're getting back a Boolean mask, returning a 0 everywhere where the input is the empty character, and a 1b where they are actually different. Now, this works because KDB operators are atomic. What does it mean for an operator to be atomic? An atomic function extends its functionality, its operation, to every element of its list. So 1, 2, 3 plus 4, 5, 6 actually becomes 5, 7, 9. And a little side note, lists need to be the same length in order for this to function. Otherwise, you will get a length error. So now, let's look at the reverse keyword. As the keyword already says, this one is straightforward. It will simply reverse the input. So Hola Madrid becomes Dear Dam Aloha, and reverse 1, 2, 3, 4 becomes 4, 3, 2, 1. Now, this is one of my favorite patterns that I discovered thanks to Stephen Taylor. What you see here, the backslash, is the iterator scan. Now, iterators, they derive functions and apply them repeatedly to its input. Explaining iterators in detail is beyond the scope of this presentation. It will probably take 30 minutes on its own and an individual presentation, so you just have to trust me on this. This specific way of using scan is actually the do loop. So the number 1 will tell how many times to execute the function with the input x. You can also write it in brackets notation, which makes it a little bit clearer to read. So by applying this to our reverse function, we receive Hola Madrid and its inverse as an output. That's because scan, when you use it with a monadic function, it will, as a first thing, output the input, then apply the function to the input and return the modified input. Again, a different way of writing this is in bracket notation. Next, I want to explain you a little bit the concept of the do loop. Before I was using only one because I only wanted to execute it once, but if we actually want to execute it for a number of times, given a function there 2 times, we can actually run it 10 times. Now, the 2 here is again because scan, given a monadic function, it will output the input first and then apply it. So 2 times 2 is 4, 2 times 4 is 8, and so on. The over iterator, on the other hand, will only return the last result. So while scan will output all the intermediate steps, over will only output the last one. We can also do this with a different function. We can do actually the square. And now, as you noticed, once we reach this point, we're going back to 0. That's simply because we're breaching the limit of numbers. Now, keeping this in mind and going back to our example, if we would use the over for this pattern, we would only get the reversed string back. But we actually want both the original and the reversed. So what we're doing is we're combining the Boolean mask from the beginning with the reverse pattern, and we will receive two Boolean masks, the original one and the reversed one. Now, let's have a look at the question mark. The question mark can be used as a find operator. Given a list and an element on the right of the question mark, it will search for the element in the list and return the index where it's found. Now, in Q, we actually start counting at 0, so 2 is at element 0, 1 at the first one, so we get back 1. Now, what happens if we have several 2s in the list? The problem with find is it will only return you the first index, but in our case, that's actually the exact thing what we want. So we don't have to worry about this. In case you need all elements that are equal to 2, you need to use a different operation. So if we search our Boolean mask for the first true element, we will return the index 3 because it's at the index 3 of the Boolean mask. Now, how about if we want to search several Boolean masks? Now, a Boolean mask is nothing else than a list. In this case, we have a list of lists. So if we try to find the first occurrence of 1b, you might expect this to work, but it doesn't. It will return 2. Now, this list has only 2 elements, so index 0, index 1, 2 is outside of the range. So why is that? Well, this just emphasizes that if you search for an element, it will return the index where this element would occur if it's in the list. And 2 is outside the list, so 3 would have to be at the end of the list. Now, why is that not working? Because we need to search each list for 1b. So we can use another iterator, the each iterator, and combine it with the question mark, the find operator, to search for 1b in each of the lists. This, in fact, returns 3 and 6, as expected. Now, to be precise, we would actually have to do question mark each 1, 1b. Now, why is that? Because when I told you Q operators are atomic, it means that both lists need to be of the same length. However, Q is smart enough that if you have only one element on one side, it will automatically extend it to the same length as the other list. Now, combining everything, we can simply find the first 2 indexes that are actually true in our Boolean mask. And from here onwards, our program is actually pretty straightforward. So instead of getting the first one and this one here from the reversed list, it's actually the last one that is true. So in order to get the last one, we have to multiply it with -1 because we're going backwards. So again, because KDB is atomic, it's really easy. We have 2 lists. Now remember, this operation returns 3 and 2, so we can use multiply with 1 and -1 to get 3 and -2. Now let's look at the underscore, which is also the cut or drop operator. Given a list on the right side and a number on the left side, it will simply drop the first n elements of that list. So Hola Madrid, 5 underscore Hola Madrid, becomes Madrid. Now, remembering this and combining our drop operator with the over iterator, we can see that we achieve exactly what we want. Now, over, as I told you, will only return the last output of your operation. So it will first take 3 elements from trim the spaces, remove them from the front, and then -3, remove them from the end, and return trim the spaces. Now, we can also write it with bracket notation again. As you can see, we actually, inside our little lambda here, we do y underscore x. So why is that the case? Why can we not do x underscore y? Now, if we try x underscore y, we get a type error. One of the most helpful things in Q and trying to understand it and to debug it is actually the zero bang operator. It's really simple. All it does, it outputs the input to the console. And then, again, 4 is outputted because we have 4. But if we want to understand what went wrong here, we can simply use 0 and bang together with the inputs, x and y, to see what's the input to the function. Now, this is going to be our x parameter, and this is going to be our y parameter. So you can see that the first input x is 3 and -3, and the y input is actually the empty char. Now, because I told you over will derive a function and then apply it repeatedly to its input, it will iterate over all these inputs. And because a string is nothing else than a list of chars, it will use the first char as input first, then it's gonna do the operation, and then use the second input as a second y input. But the type error here is simply because this is a char and this is a list of numbers. If we use the drop operator with a list on the left side but only one element on the right side, what it does, it actually removes the element on the at index 1 from the list on the left. So you can see index 1, 0, 1 is the 2, so it will be removed. Now, this is not a number, so obviously you get a type error. Now, let's try to make a list out of this. So we have two lists on each side and have 3, -3, drop, trim the spaces. Now we're getting a domain error. Why is that the case? Well, as you can see, we get the domain error. Why is that the case? Now, as most operators in Q, they all have several overloads. Now, if you use the drop operator with a list on the left and a list on the right, it actually becomes the cut operator. Now, the cut operator works kind of like a scissor. So if we have a list till 15 with 15 numbers, and we use 369 on the left side, what it does, it will cut at these indexes. So it will cut everything from 0 to 3. Index 3, then the next cut is at 6, and the next one at 9. So if you want to include the first part, you just amend a 0. But if you have a negative number, there are no such things as negative indexes. So that's why you get a domain error. And that's pretty much it. This is just like another example showing you why the empty character isn't working. And you're getting a type error. Once we fix this, we simply get the result that we expected, and it's working perfectly fine. Now, I have prepared another little explanation. How are we doing time-wise? Do I still have time? Yeah? Okay. So a few weeks ago, Habla Computing, they actually posted a little challenge on LinkedIn. So the challenge was like, given an n-by-n matrix, change all the numbers below the main diagonal to 1s. So, and this was the solution Habla Computing came up with. Again, you can see, if I would not know KDB, I would be like, what's going on here? And this is one of the main problems with Q. Like it's a very terse language, and once you reach a seniority level, you kind of see it as a challenge to make the code as short as possible using variables named that make absolutely no sense to anyone else, m, x, n, so that once you've written the code and you put it in production and then a few years back you come back and need to fix it, you have to sit down and actually think, oh my God, what was I doing there? Anyway, so this was their solution, so let's walk through it. As you can see, it actually produces, it converts the n by n matrix and puts ones below the main diagonal. Now, why did it not work in the first case? Well, I simply selected random numbers 16 from 0 to 10, 10 excluding, which means that the 1 is going to be in different positions as well, so it didn't substitute it. But as you can see, if I increase the range from 10 to 100, I'm not going to have that many ones. Okay. So the question mark on top of being find, it's also a random number generator. I can generate 16 random numbers between 0 and 100, 100 excluding. So here are my 16 numbers. The hashtag is either the take operator, or in this case, with 2 numbers on the left, it's the reshape operator. Reshape because it's reshaping my list into a 4x4 matrix. Now, if you need a 2x8 matrix, you can just use 2-8 reshape. If you're not sure about how many columns you want, but you're sure that you want 3 rows, you just use 0n, the null operator, for the columns, and they will generate you 3 rows and adjust the numbers accordingly. So you have 5 elements in the first 2 rows and then 6 in the last one. Now, let's store this in a variable v and then output it. Next, count. What does count do? It's very simple. The keyword says it already, so it counts a list. So counting 1, 2, 3, 4, there are 4 elements. Now, if we count v, that we know has 16 elements, why do we get 4? Well, let's use our 0n bang operator again. Outputting v, we can actually see that, hold on a minute, this is a list where each element is a list of 4 elements. So because count works on a top level, and we have 4 lists of lists, obviously it returns 4. First element, second element, third element, fourth element. So count v is also 4. Next, we have the till operator, which basically outputs the numbers from 0 to n minus 1. So till 4 returns 0, 1, 2, 3. Till count v, also 0, 1, 2, 3. Now, we can store this in a variable n. And here, as you see, is 0, 1, 2, 3. And now we do n larger or equal to n. Now, because, again, KDB is atomic and will operate on each element, it basically compares 0 with 0, 1 with 1, 2 with 2, 3 with 3. Is 0 larger or equal to 0? Yes, it is. Is 1 larger or equal to 1? Yes, it is. And so on. So you get 1, 1b. However, what if we use another iterator, the each left iterator? How does it look like? Well, it generates this n by n matrix where all the elements below the main diagonals are actually 1. Now, why is that the case? Well, the each left operator, what it does, it takes the whole list on the right side and applies it to each on the left, hence each left. So basically, it's comparing the whole list to 0 and returning 1, 0, 0b. It compares the whole list to 1, returning 1, 1, 0, 0b, and so on. Now, you can also write this differently with just using each rather than each left, by creating a projection. Again, projections are beyond the scope of this presentation, but if you have any questions, please feel free to reach out to me. We create the lambda here. We have x larger or equal than y. We fix the y parameter, which is here, this one, because we always use the whole list, right? So we have it as 0, 1, 2, 3, and we loop over each element that corresponds to the x elements. So basically this here is equal to this, and they're both equal to what those 4 statements would do. So again, we get back this n by n matrix with all the numbers below the main diagonal being 1. Now, we can simply negate that to get the inverse. And now it's pretty straightforward. We have the inverse here with zeros below the main diagonal. We multiply it with our input x and then add m, which was the matrix here, if you look at it, that has the ones below the main diagonal. Now, matrix addition, again, it's because KDB is atomic. Where's the slide? Here, A, B, A plus B, it simply adds every element together. Now, multiplication, again, it's atomic. It does not do a matrix multiplication in the traditional sense, but it will multiply every element with the corresponding element in the other matrix. So if we look at not m, right, 0 times whatever is always 0, so v times not m, it will only keep the elements above the main diagonal. And then all we have to do, we add m, which was the ones below the main diagonal, to get exactly what we wanted. Now, where do we go from here? It's pretty simple. Read my blog. And you can find it at DefconQ.tech. Also, follow me on LinkedIn for updates. And thank you very much.
Okay, thank you very much. So is there any question in the room? Yep.
Okay, thank you very much for your presentation. Very, very nice. Really nice and very well explained step by step, all the samples and so forth. So thank you very much. Just one thing that I would like to mention is that concerning the resources for starters. In our experience, it was really great, the KX Academy notebooks. I use it personally with my students, and we also use it at Habla Computing. Mm-hmm. We also develop some notebooks and some training material and resources for our trainings. But the start, the very first start, they work really, really great.
Yeah.
KX Academy notebooks. Okay, and then you can go for QTs, for mortals and so forth, but as a first start, it is fantastic.
Yeah, so when I actually started KX Academy...
Yeah, you are a seasoned professional and you are a seasoned KDB programmer.
No, but it was not around. So
not.
like the problem with Q is it's very niche, it's very rarely used. I started in 2015 at Citigroup during the grad scheme, so I'm not coming from the traditional route via KX or Data Intellect. So I didn't got the internal training they have nowadays. And back then, there was only codekx.com. Mm-hmm. There was no KX Academy. There was not the community that exists today. There was no DefconQ, my blog. So it was actually much harder to learn Q. And I'm still lucky, because if you go back 10 more years at the early 2000s, there was no documentation at all. All they had was a mailing group where they could send an email and hoping that one of the more senior developers would answer your question you had. And when I first started, I actually signed up and it was very intimidating. Like, I didn't dare to ask like a question because I felt like they're gonna laugh about me. Why is someone asking something so basic? But over time, like, you know, the community grew. People started to build more learning materials. KX, they bought the book Q for Mortals and open sourced it, like they made it available for free. They started the KX Academy. I started to go through it, and I agree, it's a very good starting point. It's definitely helpful. It depends on what kind of learner you are, whether you like to watch videos and tutorials and then follow them, or whether you prefer a book. So I think KX Academy goes well together with Q for Mortals. Data Intellect, they also have an amazing bootcamp that's used to train the graduates. I was lucky enough to get access to it. It's not publicly available, but I know that companies can buy it from Data Intellect. But I'm not here for business, so please reach out to Data Intellect for the bootcamp directly. Any other questions?
No more questions? Remember that you can post your questions on LinkedIn if you want to, and we can read it out loud here. So if there are no more questions, thank you very much again. Yeah, sorry. Yeah, it's complicated. This goes like this.
It's on the other side.
Okay.
That side. Oh, goodness. Okay. Right. Righty-ho. Right. Hello, my name is Zan, and I'm going to be talking about migrating KDB Plus applications, specifically Torque, onto the cloud using Amazon FinSpace, or Amazon FinSpace with managed KDB insights. So just very quickly what I'll be going over. I'll be going over who Data Intellect are, the company I'm representing today, what a vanilla or standard KDB setup looks like, so we've all got a base point, what Torque is, then what Torque on managed KDB insights looks like, what it actually looks like with a few screenshots, and what we're working towards next now that we have our minimum product out. So who are Data Intellect? So at its core, Data Intellect is a global data and technology consultancy firm. Primary market is in financial and capital markets technology solutions, but we also do work in smart energy and healthcare, so we're not purely based in capital markets. Data Intellect also doesn't just do KDB. So center point there is our KDB kind of section. We also do like low latency Java, C++, and things like AI, modeling, analytics as well. We have quite a few clients. We work with 8 of the 10 top tier 1 investment banks, and you can see a few of our partners just up there, including KX and AWS, and this is growing kind of daily at this rate. So this is what a kind of standard KDB setup looks like. This is just an architecture diagram that I wholeheartedly stole from KX's website. So just briefly going over it. Starting on the left here, we've got our incoming data. So data comes in from data feed, and it comes into a feed handler. This is just a process that essentially transforms your data into a more KDB-friendly format so that your ticker plant or other processes can understand it. So moving on to the ticker plant, this process does a couple of key things, but the main ones are it will write down incoming data or what it receives into a log file. This is so that we have kind of tracking of what information is coming in, and also for recovery purposes if we need to replay the day's data. And next, ticker plant will send data along to anyone that is interested in that data. So that could be your real-time database, which I'll go over in a moment, but it could also be a real-time subscriber, so any process or any person that is interested in the raw data from the ticker plant can subscribe to get it. And you can subscribe to receive all data, or just a subsection or a few subsections of it. So on your databases, you have a real-time database, which is normally set up to be the day's data, so today's date's data. Not always, but standard setup, that's normally what it is. At midnight or end of day, that data is written down to your on-disk location, and then your historical database, your HDB, is reloaded so that your RDB is ready to take on a fresh day's worth of data, and any data that was taken in is now available in your HDB so that it can be queried by your gateway. This is normally the user's entry point. So user go into the gateway, and they will send queries off for data, and those queries can go through either the RDB, HDB, or both. So this is what Torque looks like on premise. So Torque is Data Intellect's open source KDB framework. It was released in 2015. It provides the building blocks or the core materials needed to start up a production system. It's widely used, and kind of key part of it is that you really don't need to know much KDB to get started with it. It's built so that you can get started, up and running as fast as possible, and then you can build on top of it and make it kind of your own after that point. So you can see we have all of these standard processes that you would need. So starting from the top again, we've got feed handlers, ticker plant and RDB. And then moving over, we still have our HDB and our gateway. We also have a few additional processes. First one being the discovery process. This is often called a broker in some companies as well. This is a process that keeps track of what is alive, what processes are up and running at that moment, and it can broadcast those processes to other ones. So for example, if the gateway wants to connect to every RDB that is up and running at the time, it can tell the discovery, I want to know what RDBs are available, and the discovery will send all the details it has available, but that also keeps a running track as well. So if a new RDB was to come up at any point, the discovery process would broadcast that availability of this new process to anyone that's interested, in this case, our gateway. We also have a WDB. This is a writing database. Something similar can be called an IDB as well. And this is a process that primarily handles intraday or end-of-day writes, so it frees up your RDB to solely serve user queries. We also have a few additional processes, such as housekeeping, monitoring, and reporting, which do pretty much what their name suggests. Monitoring process can monitor your other processes, reporter sends out reports, and housekeeping just does a little bit of cleaning up and things. So how do you get Torque up and running? Torque consists of two code bases to get it up and running. You have your standard or your Torque framework, which is on the left here, and then you have an application code that's needed. We have several application codes, which we call starter packs. Main one that's normally used is our finance starter pack, but to get Torque running up in FinSpace, we had to make changes to the standard Torque framework so that it was forward compatible with any existing starter packs, but also so that it was now going to be compatible with this FinSpace. So we had to create a new FinSpace starter pack to go along with it as well. So this is what we came up with, and this is our Torque MVP. It does still have the majority of the systems available, such as a gateway, a discovery, RDB, HDB. But there was quite a few things that needed to be changed or removed. So you'll see it is quite a lot smaller than the image before. Big reason for that is that we don't actually need a lot of those additional processes anymore. The reporting, housekeeping, a lot of that can be handled with AWS's kind of inbuilt applications, not applications. Can't remember the word at the moment, but it can be used with AWS. Right, but we did need to add some additional components as well, or some changes. So an example is our discovery API had to change. We integrated with AWS's own discovery APIs. Our logs, instead of writing to disk, we're now sending them to CloudWatch. I'll go over these in a little bit more detail in a moment. And finally, our end-of-day process needed to change as well. So, changes that needed to take place, or the more interesting of the changes anyway, are disk access. So, disk access changes needed. In AWS, we were going for a complete system on the cloud, rather than having a hybrid environment. So, our logs could no longer be stored on disk. They now needed to be sent to CloudWatch, and that is a service. That's the word I forgot earlier, an AWS service, not an application. So that's a service that everything that goes to standard out and standard error can get written to CloudWatch, where you can view your logs. Ticker plant logs, a very similar fashion. We no longer had access to on disk, so our ticker plant logs had to be written to something called shared storage, which is a shared space where your ticker plant and any interested process, normally your HDB, can access that log file. And our end of day as well had to change because we're no longer writing to an on-disk database. We are now writing to an S3 bucket or creating a change set. Connection-wise, what needed to change? Torque normally handles connections via host import hopen. AWS use something called connection strings. They're a lot more secure, they're a lot larger. They work the same as an hopen, but it's no longer just a simple host import opening like it was previously. On that same note, the discovery process had to change. It got a little bit of a downgrade. So instead of now sending out host import details to any processes that are interested, it now just broadcasts the existence of processes, and each individual process would handle its own connection details. So it would generate its own connection string and connect via that way. Our connections did time out quite a lot as well, just security reasons. So we have enabled heartbeating in Torque, so that it just keeps those connections alive. It's just a pulse that goes to each process every now and again, just to make sure the connection stays alive. So security-wise, what needed to change? Only Q scripts are allowed. So we did have a few like CSV files, things which you can use as configuration, but loading code-wise is only a Q script, so you can't have other languages. System commands are disabled, even simple commands like sleep. AWS are working on a blacklist or a whitelist at the moment of them, but moment, all disabled, so we had to go through the code to find all those instances and fix them. And .z commands as well, there's a little change there. Instead of just reassigning a .z command like you normally would, we had to create custom wrapper scripts that would redefine them for us. So instead of redefining .z.pd, we had to redefine .awscust.z.pd. So with all these changes, we actually built a little tool to help ourselves going forward. So with this tool that we built, you just tell it where the path to your code is, path to your Q files, and it will scan all your Q files for you and output a CSV with details on what may be a problem in your code. So it will output all the areas where .z commands are reassigned or where you're using system commands. And it will give you all those details, where they are and why it thinks it's an issue. Just a very brief example of how this can be helpful. We had a very, very small system, which was 3 files, and it only had 5 lines of code that needed to be found. We had somebody go through this manually, and it took them 5 minutes and 41 seconds to find all 5 lines of code. We had our scanner go through it, and it took 1.89 seconds. That's like over 300 times faster looking at this. And that you can see clearly why that would be quite a big help. But it's not just the speed that's a key area here. It's also it's less user error prone. So you're more likely to catch all the instances first go. When I was personally rewriting the code for the .zs, I missed many of them. And I had to go back and fix them many times. So this would have been a big help going forward. And this is going to be part of a service that Data Intellect is going to help offer with helping other people migrate their KDB systems onto the cloud. So it's going to be part of our package for it. So moving on to what does this system actually look like on AWS. So here I have a demo environment set up. I've got my 5 clusters, which is what AWS call their processes, up and running. So top to bottom, I have my trade feed, which is a process which generates some demo data, some sample data, so that it's to my RDB, so that you can see more realistic data coming in for this sample. I have a gateway process, or entryway for our users. I have my historical database, my HDB, my RDB, and my discovery. If I was to click onto one of these processes, you can see quite a lot of monitoring metrics. Now, this is one of the reasons why Torque had such a reduced version going forward. We no longer needed a lot of the processes that we had for a standard Torque. And this is because AWS provide this kind of just out the box with each of your processes. So you can track each process using CPU, memory, and you can create dashboards of these metrics. So you can compile all your RDBs together and just look at the memory of all of them all together on one dashboard. And you can also set up alerting for these as well. So you don't have to build custom Q scripts to do that for you anymore. You can just do that using AWS's services, which can be quite handy if you're reaching your memory limit. Now, as you can imagine, this is my demo section, so my graphs are quite flat. But if you were using this kind of real life, it would be a wee bit more spiky and a wee bit more interesting. So this is what your logs would look like. This is a kind of this is a view of your logs. a demo sort of your logs. Now, we don't expect you to be reading torque logs like a novel. They're not all that interesting. Most of them will be heartbeats. But if you have issues, logs are the key places to go. So going to actual CloudWatch, we would be more expecting you to use your log files like this. So you know there was an issue between noon and 1 o'clock. So you can search timeframes for your logs, or you can search for keywords as well, which we provide in our documentation, a few keywords to look out for in your log files. And a little bit on what it looks like from a user perspective. This is just our gateway connected here. I have created a custom API here in my gateway. Torque is designed to be customizable by you when you're using it. So that's what I've done. I've created my own API. And my API just prints out the last price, cumulative price, average price, and my VWAP for my data that was in my RDB and HDB at the time. So what we liked about this, it was really easy to get started. Documentation, there's lots of it with images, step-by-step processes. It's quite easy to get up and running from the get-go. The flexibility and scalability that this offers you as well. So on-premise, you're usually having to think about what will my HDB look like in 2-3 years' time down the line, so that you can get the hardware you need for that memory. You don't need to do that in here. You've just got the option to pay for what you use. Resiliency as well is quite a big point. You have multiple availability zones, which are like if you have your processes on a host, if your host goes down, your process goes down, and you're normally having to then enter recovery measures. But with this, you don't need to majority of the time. If your availability zone goes down, then it will pop up on another one. So it will keep it alive for you. So it's got that kind of rolling resiliency for you. Logs and metrics as well, all go into CloudWatch. Anybody that's dealt with old KDB systems, any legacy systems, will know your logs can be a little everywhere and a little difficult to find for specific processes. You know where they are with this. They're all on CloudWatch, and you can easily find them just by searching for your cluster or your process name. What we're working on now is our ticker plant and replay functionality. This is actually already finished. It's just waiting for our next release cycle to get it out there to everyone. Adding more monitoring and tooling. So this is mostly looking at what AWS have available and inbuilt for them, and how we can integrate this with Torque and anything that we can offer as standard or as an option. Adding unit tests and failure and recovery logic, and just in general making the code base just that little bit better, more resilient and more usable. Right. Just to round off here, one of the bigger things that we have been working on is this idea of scaling. So this is cluster scaling. So just a little image here that shows us what your expected usage of memory would be. So that is our blue line that's going kind of more steadily along. And then what your actual usage could look like, which is the red line that takes quite a big spike. If this was to happen midday with one of your processes, your process could crash and run out of memory. This is just on any process. This has probably happened to a lot of people that use KDB systems long term. So to try and fix this, we are using what we're kind of calling a rolling system, where we have a couplet of processes. So we will have an RDB, a WDB, and a HDB, and these will kind of roll over and start up every 2 hours. And those processes would only be responsible for their 2-hour, did I say minutes? Their 2-hour window. So your RDB and your WDB would take in data for those 2 hours, and anything that comes in outside of those 2 hours, it wouldn't care about. The next set will deal with it. And this will kind of allow us to more steadily control the data, the amount of data the memory is using. So we're less likely to run out of memory, and we can start up larger clusters next time as well. So if we are using up 80% of our memory usage by the time the 2 hours are up, then we can just start a larger RDB and WDB next time round. Right, that's just it from me. Right, thank you. Any questions?
Thank you very much. So, any question? Yep.
Hi, thanks. Great talk, really enjoyed it. So the couplets there, they're doing it on an hourly basis. Did you consider doing it on a memory basis, or do you know, like in theory, starting every couple of hours is going to address a lot of the problems for sure, but I guess, are you looking at doing it also on kind of memory usage and sort of, okay, I'm approaching a limit, so I'll start one now?
Yes, we are. So kind of as standard, we're kind of, you can customize the time window that it comes up at as well. So it doesn't need to be every 2 hours or 1 hour, you can customize that. But yes, their AWS allow you to monitor the metrics, so CPU and memory. So we have set up alerts where once it reaches 80% of its capacity, then it will start up a new RDB, which can then take over from the previous one. And the previous one will just set so that it can still serve user queries and you won't lose any data, and this new RDB will be taking in new incoming data. And then the next set that comes up would be like a larger RDB so that you wouldn't need to do this kind of bringing up a spare process in the long term. So yes, we have been.
Okay, more questions? Well, I have one.
Yep.
So, in general, if you can say, are your clients moving to the cloud? In general, the people who were using Torque, or
sorry, I'm not. Yeah,
are they moving to the cloud? Are they, or they are still standing on the on-premise?
So I'm not understanding you.
Okay, sorry.
Going about.
Yeah, I mean that you are providing a solution to migrate Torque applications to the cloud. So in general, are the companies that were using Torque moving their solution to the cloud, or they are reluctant to do that? Is that clear?
Yeah, we are kind of offering, we're starting to kind of offer services for people who are using Torque to migrate to this. But we're also looking at people that are more interested in a hybrid environment. People might not want to move everything over at once. They might want to start by moving their HDBs up there, because that's usually the biggest memory point. But yes, it's not just people using Torque as well. We're helping people migrate over that have just their existing KDB systems, or even new systems as well. Torque can be for new or existing users as well. I'm not too sure if that answered your question.
Thank you.
Right, brilliant, thanks.
More questions? No? So, thank you.
Nope, thank you very much.
You can use this one, and we can leave that microphone for Aoife.
Sure. Yeah, yeah. That's on here.
So this goes like this. Yeah, it's weird.
Cool. Feels totally normal.
Yeah. So make sure that the pocket is normal.
Oh my gosh, this is okay. Like that?
Yeah, like that.
Excellent.
It goes into the back.
Perfect. Can you see this?
So the next one to talk later.
Oh wait, I have to do it this way, don't I? Oh, duplicate.
If it's going to talk later.
Aoife's going first, actually.
Okay.
Up you pop. Do you want the microphone or do you want this contraption? No. Oh, good.
Hi everyone, thanks to Habla for having us. My name is Aoife Clarke. I head up business development at INQDATA. I'm joined today by my fabulous colleague Rebecca Kelly, who heads up our I'm here, I'm going to talk a couple of minutes to give a bit of context around who we are and what we do. I'm going to pass over then to Rebecca, who's going to put some meat on the bones and flesh it out for us as well. So, INQDATA, we are a market data as a service offering. Some of you will be familiar with us, some of you won't be so familiar. From Alex, how to learn, read and understand KDB. We heard from Zan about how we can take those applications and migrate them to the cloud using AWS, Space and Insights. I am going to take about 5 steps back. So firstly, how do we get hold of that data? We think about typically larger, chunkier data sets like your level 3 or your unconfigured data. How do we get hold of that? First time I come back and learn.
Do you want this one?
I did.
Okay.
Is it okay?
Do you want this?
Yeah.
Carry on. Sorry, some technical difficulties. Yeah, so how do we actually get our hands on that data, right? Particularly those larger data sets. Once we do have that data, how do we get it into KDB? And once we do have it in KDB format, how can we leverage the cloud capabilities to help us manage that data on an ongoing basis? So that's where we come in. That is where we come in.
Just press the button.
Fabulous. Okay, fabulous. Yeah. INQDATA, like I said, we're offering market data as a service. So we're really working to transform the way that financial institutions are A, accessing and B, managing their market data. Okay? So offered as a fully managed service, we're leveraging the benefits of cloud architecture and KX technology to provide our clients with seamless integration, massive scalability, and performance capabilities without additional resource overhead or any of these infrastructure complexities. So really, what our clients get to focus on is deriving value out of the data without all the overhead. So if I take you through this bit on this box on the left, we're managing that entire pipeline for our clients, right? So if I take a recent client example where they have a client approach us because they wanted access to a level 3 data set, right? Really big, oftentimes, our central market data teams are so busy, it's not something that gets pushed right to the top of your priority list, right? Rebecca, you can keep me honest to give a bit of context as to how big this was. Stay still. Stay still, speak louder.
Like this?
This is where, yeah, it's so weird.
Okay. Like, sorry. Oh, it stretches? Okay. Does this work?
Yeah, it's working. I'm trying to keep the microphone.
There we go. Okay. Perfect. Yeah, so Rebecca can keep me honest on this, but to give context to the size of this specific data set, I think 1 year North American equities level 3 data was around 65 terabytes. So we were able to ingest that data. We were able to hydrate it within the client's chosen cloud environment. What we then did was tune our system for the best performance for that client based on their unique cost and usage profile. What we're then able to do is take all of that and distribute that data back to the client in their chosen delivery format using a range of intelligent APIs that we've built. Now again, in this, given it's a KDB event, the client's chosen format was KDB, right? And that means that our clients are getting everything on the right. So we're doing everything on the left, client gets everything on the right. Access to reliable data, focus on adding that value and decision making for the client, access from their existing infrastructure, and we're a fully managed service. So there's no support or maintenance concerns, it's all covered by our team. So we're experts in KX and KDB. We're experts in cloud computing, and we're experts in data management, okay? It's not the funnest of things to be an expert in, but somebody's got to do it, right? And we sit right in the middle of all of these. We are sitting at the intersection and a one-stop shop for our clients' market data needs. We're able to manage all of that high-touch, non-core, really resource-intensive work for our clients. We're keeping the lights on, essentially, and freeing our clients up to focus. Again, I'm going to sound like a bit of a broken record. It's a really simple value prop here, guys, getting value from your data, okay? So, given we are at a KDB developer community event, it only makes sense to talk about KDB-specific use cases, and Rebecca is going to go through those with you in a moment. What I do want to point out, however, is that whilst we are powered by KX technology and we're leveraging that for the benefits of our client, we are able to deliver the data to our clients in their chosen format, regardless of what that is. You can have it in Python, you can have it in React, you can have your data delivered by a carrier pigeon if you really wanted. Probably not the most efficient way, but the point here is that in order to leverage the benefits of INQDATA's system, you don't need to have any pre-existing KDB plus or Q usage or knowledge within your organization. The benefits are still there for you. So, why Quant data made easy? Again, as a market data as a service provider, INQDATA's offering is applicable across a wide variety of use cases, both on the buy side and the sell side. So you've got compliance, surveillance, regulatory, market analysis, market risk management, a whole range. But we've chosen today to focus on an area that we've seen real interest and actually quite a few challenges across the community in as well. And that is these. Realistically, right, we know that a lot of quantitative analysts and data scientists really struggle to A, access, and B, manage large volumes of market data. We also know that that inability hinders their ability to derive these insights and complete this in-depth analysis. And this can be for a wide variety of reasons, right? Your central market data team could be at capacity. Just because you want a data set doesn't mean it gets pushed right to the top of the list, right? Your own team could be heavily under-resourced, and you're sitting there just trying to keep the lights on. So whilst you could be a genius and have 101 fabulous ideas, you're not going to get the time to put them into play or try them out, right? The data set could just be too large. We talked about level 3. If we look at sort of, an uncompleted opera set, any number of these data sets, right? Too large to manage without you having to go and build additional infrastructure to, again, manage and store that data. And that's notwithstanding the cost of all of that as well. Or, you might just want to switch up your market data provider, right? You might want to change vendors. You might, for example, prefer how one manages their conditional code formatting over another, or prefer one's quality over another, or whatever that might be. But you struggle with vendor lock-in because the perceived cost of any migration outweighs the benefit of any switch, right? And again, this is back where we come in. We're sitting at the middle of this intersection, and our clients are able to get immediate access to model-ready data in their chosen format. So hypothetically, you could decide on a Friday afternoon, hey, I want access to 5 years worth of Bloomberg tick history data. Go and enjoy your weekend. We'll burn the midnight oil for you, and you can come in on a Monday morning ready to go. And on that note, I'm going to pass over to Rebecca, who's going to show us how we simplify access in KDB to this data set.
Okay, yeah, okay. Bit of my hair touched. That's so sorry.
Sure, this thing. Okay. I'm a pro now. Once you get this thing on once. Okay, great. Everyone can hear me? Cool, excellent. Yeah, so this is me coming in Monday morning. Thank you for that. After we've been, as Aoife said, doing the midnight oil and getting all the data set backfilled. So I'm going to talk about two things, really, right now. I'm going to, firstly, because I know it's a mixed audience, we've got some people who are totally new, we've got some people who are more advanced. So I am going to kind of try and satisfy everyone's curiosity. First, I will look at, I suppose, what that quant does when they get into that environment and do some basic time series analysis. From beginners, I'll kind of show you, basically from our APIs, what the sort of underlying kind of KDB code would be for to kind of produce some of those outputs. And then I'm going to take a step back, not as far back as Aoife, but I will talk about what is kind of happening architecturally and on the back end for that kind of magic backfill that's whizzing its way over the weekend into the system. Yeah, perfect. Okay. So I don't know if I'm braver or just more foolhardy than Alex, but I'm going to attempt something a bit live. And so what I'm looking at here is a Jupyter notebook with a KDB kernel running on it, okay? So I know Aoife said a few times there, you don't need to have KDB to use us. That's absolutely true. We have the same sort of equivalent ones in Python, for example, with the Python kernel. But you know those sayings, it's like you don't have to be crazy to work here, but it helps. What I will say is that the KX interaction is going to be the most performant way to pull out your data for a lot of different reasons. If for no other one, then the way KDB transmits the data is nicely compressed. So if you're talking about cloud and the egress costs from pulling from one environment to another, you're just going to get benefits there kind of out of the box. A bit larger? I see what you're saying. Yes, I can do that. I'm sure. No, not too much. Better? Everyone can see? No, that's too far. Okay, great, thanks. Okay, so I am a quant. I'm coming in on Monday, and I want to look at some data that has been backfilled from the Bloomberg tick history over the weekend. So this here is just another way of making a dictionary. I have it in this format using the flip, just because I find it's a little clearer for people then to see exactly what the inputs are for each of these sort of values. So we're using a dictionary here to pass to the API to then kind of get the return that we want. So we're just going to get some market trade data. Yeah, simple, straightforward. It's for this particular time range and for these particular tickers. This is a big notebook, so I'm going to try my best to get through it. Okay. Again, beginner KDB people, you might want to filter your data. So you can see up here that we've got condition codes that are associated with this. Aoife mentioned that some data vendors have, maybe more sophisticated ones or more normalized ones than others. But however, we have baked in to our system an ability to sort of configure the codes that you care about and that you want or don't want. So you can kind of quickly return throughout all the different APIs. So like this one's pretty standard because it's just raw data, but it gets a little bit more interesting when you're looking at bucketing data, for example, and you want to leave out certain types of trades. Here, if you are a beginner KDB developer, you might do something like this to achieve that. You'd say, filter these out. So give me the market trades where they're not in this list. This is going to, if we do that 50 times, it's going to take however long it takes, I guess. But you can also do something like this, right? This is function composition. I'm not going to get into it in too much detail, but I think Alex mentioned Nick Sar's books. He has two. His second one, the AI one, actually uses a lot of kind of neat function composition. I'd recommend. It's a worthwhile read. So if we do it this way, even though it's also, sorry, yeah, I didn't explain this. This is just doing the time and space, repeating it 50 times for that query, so that we can kind of do a little comparison. So, it's not a lot, but every little kind of helps. So when we're talking about kind of performance, and if you are sort of running a huge market data system, for example, with lots of user queries. Okay. Other typical things you might want to do, bucket your data. Look at kind of what's happening within particular time intervals. So here we're doing 10-minute buckets on the data. We're getting open, high, low, close. We can, so here's where, for example, if you're pulling in and using the filter, you can kind of see that like it's not the same amount of trades that are being included because that's already sort of filtering through. But if you want to do this from scratch, you want to use the xbar keyword, yeah? That's the one that is going to take the input and sort of slot it into those buckets. I'm using .minute here on the time column, but you don't have to use, you can use a time span, for example. You can say, oh my gosh, this is why I don't do this. You can use time spans either as well, but I'll just leave that as it was. So another thing to point out is the volume weighted average price is just using the keyword weighted average in KDB. Sometimes people might want also the time weighted average price rather than the volume weighted price. In which case you can just do the same thing, except instead of using the size, you can use the time intervals basically between things. Something to point out is that you would use this kind of previous command in KDB, but you'll notice here that the first one doesn't really get filled in, so just something to take into account that you have to fill that in with this little hat guy with the appropriate time. And you can then have your time-weighted average price. Yeah. Okay, cool. Moving on. Combining data sets. We could use as-of joins. If you are new to KDB, this is a really cool join. It's the one that is used. Well, it's certainly the one that was revolutionary at the time when it first came out, because it's so focused on the typical quant use case really all the time. Like you want to know what things are with respect to the current market. And that really wasn't available in other languages when it first came out. I know some things have it now, but KX was first. So if I get some quotes data, I can run this as a join. So this is going to take a little bit of time, even though I'm filtering by security here, because I'm not really running on a very big box. It was a lot faster when I used the API, for example, because, well, for a lot of different reasons. At the back end, you know, we're handling all the kind of compute and the crunch. So we have, you know, bigger boxes that we're running on, and we're kind of optimized for that. In terms of syntax and how this works, the first input to the as of join are the columns that are going to be used to kind of create how that join ought to happen. So date and security are going to be exact match columns, and then whatever one is at the very end is your kind of soft time-based match. So for example, like if I've got a trade and it happens at 10, it'll look for the quote that happened kind of most recently before that time. Yeah, and then the second input is kind of the table you want to keep, right? So your trades table, and then the third is the reference table. So in this case, the quotes. Yeah, makes sense. Hopefully. Okay, so put it together. We'll do like a little quick, and again, another example of what like quants often want to do is, you do your trading. You know, that worked, did it? I don't know. Who knows? I guess we should check. Yeah, so the way people typically check how good a trade was or anything is usually by like looking at the profitability after certain time intervals. I've worked, well, no, I won't. I'll put myself to shame if I start talking about that. But I've had the privilege of working in quite a few different places, and I've gotten to work with some exchanges kind of on that side of things. And some of them will kind of advise their market participants around certain things. So, for example, they would look at how people were obviously behaving within the exchange. My first actual position was, well, with KX, was out with ASIC, the Australian Securities and Investment Commission, and they were looking more for market abuse practices, which was kind of interesting. But I also did get to work with some FX exchanges. Well, specifically, well, they've changed the name, but they're part of CME now, so whatever. But they were looking at how people were doing, I suppose, within the exchange. And they would also, their salespeople or their client-facing people would look at these reports and try to kind of advise people on whether they should maybe continue to trade with some counterparties, because they had the option to turn people off, right? And a lot of, like, something that gets bandied about a bit is like toxic flow. So like people who are kind of participants in the market, but they're always winning, so to speak, right? So they had this ability for people to be able to choose not to interact with certain counterparties. And a lot of that work was kind of focused on looking at how people were doing in their trades after a certain amount of time versus certain counterparties. So I'm just have a little mock-up of that here. I also wanted to introduce the concept of a rack. Kind of goes hand in hand with the as of join. So like, yeah, so it's quite simple. It's just you basically make effectively what looks like a bit of a ladder of times and securities that you care about. And then you can kind of get your, well, this is just kind of in quote at that time, but the mark-to-market API actually will take whatever one you want to kind of pass. So in this case, I've got some internal trades, well, mocked up internal trades. I think that's what it is, yeah. And if I was using the system in earnest, I would be passing not really a rack, but these specific trade times. You don't necessarily want, as a large financial institution, to send all your data or your internal data like to lots of different places. But so this is kind of the happy in between, where you send kind of time securities. You can send whatever you like. And so I'm going to look for the mark-to-markets for these trades. And kind of bring that back. And the mark-to-market API has the ability for it to take a number of different offsets. Here it's a big return because there's a lot of columns, so I'm only going to pull back the midpoints after a certain amount of time. So this is like immediately, after 1 minute, after 5, after 10, after 30 minutes. Oh yeah, okay, for the beginners. This is something that I think we do a lot within, well, maybe not a lot, but it happens in queries. You'll also see people do sort of conditional evaluations through indexing, but that's perhaps controversial for some. But what I have here is a little dictionary that's saying if it's a buy, I want it to be a positive number. If it's a sell, I want it to be negative. And then I'm passing the side column in to that to kind of calculate then overall what the profit and loss was. And then looking at it in 5-minute buckets for each of the counterparties to get an idea of whose flow might potentially be toxic. A little bonus of a pivot. If you haven't seen it before. I think it's on the KDB side or whatever. But it's really just, yeah. Pivots are fun, I guess, if you like that kind of thing, which I clearly do. Okay, so this is the system, how it works and how someone would interact with it. So they come in Monday morning, they can play around with the data as much as they like and do whatever analysis they need to do. And hopefully that was a bit of a crash course in some time series analysis for some of the newer people out there. I'm going to go now back to this and look what we got. The same. I actually made this years ago when I worked for KX, and Espe had it in the last presentation too. And yeah, I did the exact same thing. I just went and like pulled it straight off there too. But yeah, it's funny. If I'd known it was going to become so prevalent, I think I would have taken more time, maybe. Certainly would have made some things different. But anyways, so this is the typical KDB architecture, let's say. In terms of what we do, I know Aoife has kind of said we're in the center of like cloud and management and all of that, but we do everything above the red line, effectively, is what we're handling from the market data perspective. People will always have their own sort of internal systems for doing certain things, but and managing their own internal data or that kind of stuff, but when it comes to the market data, we take it all on. It's kind of something, well, each to their own, but sometimes it's better to just have the whole problem to deal with. Okay. These areas, I suppose, are the ones that most typically bottleneck. I mean, look, you can argue and say, yeah, the real-time subscriber, if you've got some inefficient code, is going to cause you problems. But when we think about just how, in a kind of a natural growth situation, these things tend to be where you bottleneck, right? So on the kind of feed sides of things, like we're also looking at the Opera unconflated data, and I mean the growth rate of that over the last 12 years has been pretty big, as I'm sure has caused a headache to a lot of people. The gateway, yeah, you can be a victim of your own success. If you are providing a good service that people like, you find that, yeah, you're punished for that. And then the on-disk historical database, right? Because obviously that kind of goes hand in hand with the growth on the data input side. But just also in general, like, I'm going to try as much as possible to talk about sort of the on-premise implications and then the sort of cloud kind of parallels. So like, if you are working on-premise, you usually have like a box or a few boxes available to you that your team has provisioned, that went through all the kind of CapEx budget discussions. They have their boxes. And if you then decide that you want to take on a new data set and heaven forbid it be what, 65 terabytes of data. Like, I mean, you're not always going to get the warmest reception, and it's not always. It's rare that space is just like sitting around vacant to be used. So that normally involves like a kind of like just a lot of process on premises. It's obviously a lot more straightforward in the cloud environment. I mean, you still probably have to get your budget for it, but you know, once that's approved, you know, it's very straightforward. On the gateway side, a combination of, I suppose, sometimes people re-architect, or, you know, like a lot of the problems typically in KDB bottlenecks have been sort of solved like with vertical scaling, right? Throw more, like you just work off a bigger box, or you have more storage. You just kind of go bigger and kind of hope that resolves it, which, to be honest, it's very efficient. It often works pretty well, but not obviously for everything. And I mean, that's an option in a cloud environment too, but actually what I found a lot when I was working for KX before was that a lot of these bigger organizations are moving or have a mandate to move to the cloud, and they were just sort of doing let me just pick this up and like drop it over there, and they were then kind of going, oh no, this isn't any different, firstly, or it's different and I don't like it, or else it was just a case of actually the costs became a little bit more than they expected. And that's, I think, because it's an entirely new, and I will be a little bit nerdy for a second, but it is an entirely new way that you can do things. So like if you can think of a fun way of doing it, or a new way, you know, the cloud actually is very fertile ground for new ideas. So I'm going to focus on the example of the backfill, and I will try my best to stay out of any falling down wells. But yeah, if anyone wants to talk about any of those after, come find me. Okay, so for the beginners, this on the side is a typical kind of KDB H2B database on disk structure. You would have a folder, and then within each folder you have another folder for each date, typically. You can choose to partition it different ways, but by and large, and particularly with financial data, it's almost exclusively like in that format. Yeah. You have choices when you are saving to disk. What types do you want those to be? What columns do you want to keep? If you are particularly storage confined, you might not want every column from the data. Who knows? We keep them all because we don't know what people are going to want. Like from the end user perspective, we're not trying to enforce anything on them, but these are decisions that people in-house would typically have to kind of contend with. Storage medium, in terms of like what performance do you want to get from it, how do you want it to work, and then distribution. I'm specifically pointing out enumeration here on the data types consideration because, well, there's always a consideration in KX between like query performance versus like storage size when it comes to the database. So like symbols, the symbol type is much more performant from a query perspective, but it's a kind of a chunkier thing. So KDB does enumeration, which is effectively, it just keeps a list of all the symbols, and then on disk it just stores the integer of like, that's where that is in that list, which is neat, but often causes, well, it's something that I will get to when I talk about how we've kind of sped up our backfill. Yeah. So the on-premises, I'm saying like they're largely single-threaded. Like you can do things, but look, if you're in one environment working off one box, you're going to be somewhat I/O bound anyway, right? When it comes to like writing to disk and doing all that kind of stuff. So there are limitations on-prem. I don't want to necessarily dwell too much on some of these things, but a lot of the H2B kind of on-prem yeah, anyway. You can do things with, within the kind of KDB, with the partitioned or segmented databases around kind of, it will, the KDB itself kind of handles like, here's where that is and I know where that is. But we've found that actually just in the cloud, we just have a lot of different like HTTP processes and query routing. More straightforward and even perhaps like a bit more performant than, let's say, because I know with the cloud edition you can have these kind of hybridized HTTPs where you say, here's my par.text, some of it's S3, some of it's here, some of it's over there. But we found that actually separate HTTPs with routing kind of works a little bit better. And yeah, the parallel backfills is what I'm going to talk about now. Okay, so this is what it looks like in general, right? You've got your raw files, you've got to process them, you turn them into a KDB database, and that takes time. And if you're on-prem, you've got constrained resources, you can only do this in so much time. If you're in the cloud, you can parallelize it, which is cool. But I'm sure the experts in the audience are probably like, you're going to have some issues and complications and problems. Yes, this is true. So if you do have symbol types in your database, because of that enumeration, you end up like, you could either save all of these down with their own sort of associated enumeration and then go through the process of like trying to put them back together and creating a consistent unified enumeration. That's kind of like, you're getting some speed, but then you're kind of losing it. It's kind of, you're putting the brakes on yourself even when you just started to go. So that's what we did instead was, we have an enumeration service. So each of these writers, when it starts up, goes to the service and it's like, I need this enumeration for this data. It gets it, and then it just starts going through the files, making these like HTTP parts. And when it encounters something new, it just talks to the enumeration service. It's like, here's something new. And then it receives back the updated enumeration, and it continues on its merry way, pretty much. Yeah, that's like, sure, the enumeration service, that's still a bottleneck. Not really. You don't hit that many new symbols all the time. Every now and then, but like, it's not really, it doesn't matter that that's, we've not found that it has been in any way an issue or a blocker or any impediment to our speed to sort of have that need to be synchronous. Whereas, you know, the de-enumeration, re-enumeration is. So this is what we do. We have that, and now we've got our enumerated writers. And then the great thing as well is that like the HTTP parts that you make, like this is all just kind of sort of falls out from the inherent database structure of KDB. Like it's all date partitioned. So you can just have stitchers per date and have them run in parallel. So that they kind of each are responsible for a particular date. They crawl through the parts, they find the bits, they put them together, and then you have your final database. So something that would have been, you know, maybe like taking a long time to do on premises, you can do like significantly faster in a cloud-based environment, because you can obviously like spin up a bunch of EC2 instances for these. Similarly for the stitchers, I mean, they can be running. Yeah. You can also like think about the files. A lot of the file naming conventions, you can kind of get a little bit of extra stuff falling out of there, so you know what one's put where, and that's a KDB problem. This is a KDB problem. So what other? There's something I'm forgetting about this now, and I can't remember. But yeah, anyway, you throw these two instances, S3 database. Well, a lot of them would be on S3. Something I will say on that actually is compress your data, because firstly, like on-prem, If you've got compressed data, you have kind of a little extra overhead where you have to kind of, the process has to do the decompression. If you're working with a KX database on S3, compress it, because everything is faster, because the bottleneck isn't the decompression on the KDB side. The bottleneck is the kind of throughput there, and also it's smaller too, so it's like you're just winning all around, and the transfer rate's faster. It's compress it. That's if you take one thing from this talk today. Yeah, so that's how we are trying to make all of these things better. There's so many different areas and different things that we're doing on the cloud. So if you are actually interested, do come find me after. But yeah, we're making data management hopefully like so simple for people with our skills and expertise in cloud and KX. And now I'll ask Aoife if you want to come back up in case there are any questions. Or you can stay sitting, I don't mind. You're like, I'm in the heels. Yeah, happy. Oh.
Questions? No questions?
Oh yeah, sorry. Yeah, also just to say, at the end of the month, Aoife will be at Trade Tech Paris, and next week I'll be in Kilkenny at the AWS event. So if there's anybody on the stream that wants to talk in person, you can probably find us at those. Yeah.
Okay, nice. So there are no questions, so I think that we can finish the event. So we can stop the streaming. So thank you very much for attending this event. And for the rest of you, we are going to a pub, which is in that building. So you can follow us and we can do the networking there. So thank you again to all the speakers. And thank you very much to all of you for attending. So that's all.